Hi, once again. We calculated the average power and reactive power of an element already. Now there is a question asking that in frequency domain we are finding the element's voltage power and current power, current phasor, voltage phasor and current phasor. When we analyze a circuit in frequency domain, you are finding all the elements voltage phasors and current phasors. Now question is, can you find this element average power without transferring these phasors to time domain? So in other words, saying the same thing is this: can we find out the element average power and reactive power in frequency domain once we found the elements voltage and current phasors, without transferring, without going to time domain? The answer is yes, and it is a very simple way we could do that. There is a new term called complex power, is defined as this. So that means 1 over 2 voltage phasor multiplied with current phasors complex conjugate. So if it is so, this is equal to 1 over 2. V is the voltage phasor, is Vm e to the power j theta V. Theta V is the angle of this phasor. So that is altogether is this. Current phasor is Im modulo of the complex number e to the power j theta E. Theta E is the current angle. So that is now the phasor of the current, but it says complex conjugate of it. So if I put minus here, it becomes complex conjugate. So that is this now is this. So if we do this multiplication, we end up with 1 over 2 Vm Im e to the power j theta V minus theta I. So if I write this after the Euler formula, it's going to be 1 over 2 Vm Im cos theta V minus theta E plus j 1 over 2 Vm Im sin theta V minus theta I. So what is this? Is average power. And what is this? Is reactive power. Conclusion is simple, isn't it? We are saying that once you found the voltage and current phasor of an element, you're going to calculate the complex power here, as defined here, and get the real part of it. Real complex power is average, is equal to average power. Imaginary part of complex number gives you reactive power. So that is how we can calculate an element average and reactive powers in terms of the element phasors. Is simple. All you got to do is to find the complex power. That's simple. In here there is an explanation. I am not going to do it here by hand. It says how you're going to calculate average and reactive power in terms of the impedance, real and imaginary part. So you could see here, impedance real part multiplied with the current RMS current square, you get the average power. So in here RMS current square, the imaginary part of the impedance, so that X is this X here, and that Y is that Y here. So in terms of the impedance, real and imaginary part, and the current, I can calculate the average power and average reactive power. Similarly, you can calculate this average power and reactive power in terms of voltage effective values and the impedance, real and imaginary parts, as explained here. So that is end of this video now.